The title of the lesson is Greatest Common Factor, so you can write that into your notes because you have your notes out. So we're on Chapter 8, Lesson 2, and in parentheses, can you move over here? Thank you. So the title of the lesson is Greatest Common Factor. I want you to also write GCF because a lot of times we abbreviate Greatest Common Factor to GCF, the first letter in each of those words. That way we don't have to write the whole thing. So here is what greatest common factor means. We're going to take two numbers, and what they'd like you to do is you're going to be figuring out what is the biggest factor that both of those numbers have in common. So this morning, for part of our meeting this morning, we talked about prime factors and how you find how you do the prime factorization of a number, because that is one way of figuring out greatest common factor, is to do a couple of factor trees and then we compare what we see. So if I gave you a number like 20 and 30 and asked you to find the greatest common factor between 20 and 30, because those are easier numbers to find factors of, we know that 10 is a big factor and it goes into both of those numbers. Right? So 10 would be the greatest common factor of 20 and 30. So there's a couple of different ways to figure out greatest common factor. So in our notes, we're going to put both ways, and then I'm going to let you decide which way works best for you. One way really works better when you're using bigger numbers, and one way works better when you're using smaller numbers. So we'll kind of talk about that as we take some notes. Okay, so just like we've done before, remember how I told you I give you lots of tools for your tool belt, and then depending on the questions that you're being asked or the math problems, then you decide which of those tools are going to work best for that specific problem. Okay? So let's see. We're going to skip by our problem of the day for today so that we have a lot of notes to write down. Here's our essential question, is how factors and multiples are helpful in solving problems. So on your math proficiency, you'll see some word problems where they ask you about greatest common factor, so you'll have to know how to do that in order to solve those word problems as well. Okay, so here's what I need you to write into your notes. We're going to do two definitions first. So we're going to do a definition of a GCF, which remember is greatest common factor. It is the biggest factor that can be multiplied to get a number. Yeah, I knew that was going to happen. I'm going to write it again. I'm going to tell you again, and then I'm going to write it. So the greatest common factor is the biggest number or factor that can be multiplied to get a number. Now I'm going to put the word factor here above the word number, because we're really going to be talking about factors. And factor is our other vocabulary term for today. So you can have GCF there. GCF is the biggest number or factor that can be multiplied to get a product. Sure, you can change it around if you, sure. And then a factor are numbers that you multiply to get a product. Then I'm going to let you copy that down because I know that's a lot of writing. So I'm going to start with some easier numbers. Going to start with some smaller numbers that once I tell them to, you're probably going to be able to just tell me what the biggest factor is between both of them, but I'm going to show you the steps anyways, even with these smaller numbers. Okay, so if I ask you to find the greatest common factor of 6 and 12, notice that I left some space in between the two numbers because I'm going to make some factor trees, so I need some space. So we're going to write some steps down. So to find the GCF, here is step number 1. So we're going to write the steps as we do it on these two numbers. Step number 1 is to make factor trees. So I'm just going to make 2 factor trees, one for the number 6 and one for the number 12. So what are 2 numbers I can multiply together to get 6? 2 factors of 6. And we're not going to use 6 times 1. If we use 6 times 1, then we'll just our tree will be never ending. So we have to pick something other than 6 times 1. Andre? 3 and 2. So 3 times 2 are 2 factors of 6. Now if you recall this from chapter 2, when you're making a factor tree, we're finding the prime factorization of a number. So when we get to the prime numbers here, we show those by circling them. That's what I showed you to do. So if we circle the prime numbers, then it helps us to remember where our tree should stop. When it's circled, that means that tree can't go any further, that branch. So 3 is a prime number. I know that it's prime because the only numbers I can multiply together to get 3 are 3 times 1. So just like I said, if I tried to continue my tree, I would just go 3 times 1, 3 times 1, 3 times, it would just keep going on, never end. So 3 is a prime number, so we circle it. 2 is also a prime number, so we circle it. If you get stuck on the prime numbers, maybe you go back in your notes, way back to chapter 2, because we had a lesson about prime numbers, and we actually listed out all the prime numbers, I think up to 20, and we put a box around it, and you kept it kind of like a little guide to help you. So if you get stuck on prime numbers, 2 is always going to be a prime number. 3 is always going to be a prime number. 5 is always a prime number. 7 is always a prime number. So once you kind of start to memorize the prime numbers, they're pretty easy because they're always going to be a prime number. You don't have to keep thinking about it. So both of those numbers are prime. So down here at the bottom, I'm going to list out the 2 prime numbers. So I put the 6 and then the colon because that shows me that's the number I'm finding the prime factorization of. And you also notice I put those numbers in order from smallest to biggest. The reason why I did that is going to help me out whenever I'm trying to find the greatest common factor. Now, factors of 12. There's a few, right? There's a few that I can pick from. Even, I'm not going to pick 12 and 1, but there's a couple more sets of factors I can choose. 4 and 3. What's another one?
6 and 2.
What's another one? 6 and 2. So you can start with 4 and 3 or 6 and 2. It doesn't matter where you start. You're going to end up with the same answers. So I'm going to do 6 and 2. And remember, 2 is also prime. Still prime.
Can you write the prime factors numbers there?
You can look back in your notes because we did that before. So just if you go back to chapter 2, there it's in your notes. So I did 6 and 2. Circled the 2 because the 2 is prime. And then I continued my factor tree here with the number 6, and the factors of 6 are 2 times 3. And then both of those numbers are prime, so I circled both of those. So then down here I'm going to list out my prime factors of 12. They are 2 times 2 times 3. Again, I put them in number order from least to greatest. Nolan.
I was just wondering if, say, 6 was one of the factors and 12 was the other number.
Mm-hmm.
What if, their greatest common factor could be 6?
It could be.
Right?
There's 2 ways to do this, and so I'm going to show you one way and a second way. And I told you at the beginning, one way works better for small numbers like this one, and the other way works, yes. So you could have one of those numbers could be your answer, for sure. Yeah.
Oh, okay.
Okay, so step number 2, after we've made all of our factor trees and listed our factors, is to, okay, you can just follow along with me and make sure you're taking notes, and I can show you later.
I'm a GCF.
Match up the pairs. So what that means is when I have a pair, that means a number that is in both lists. I can't match these 2s right here because I'm not trying to, they have to be one from the 6 and one from the 12. That's why I listed them like this horizontally. on top of each other so that you can see. I would match up these 2's right here, and I'm going to circle them like this. Do you see any other pairs I could match up? Nolan, what other pairs? The 3's. You got a 3 here and a 3 down here. This 2 doesn't have a match, does it? No match? There's not another 2 up here. I've already used that one to pair it up, and so this 2 is alone. It doesn't have another pair. So I'm just going to cross it out so I don't get confused. Step number 3 is to multiply together the numbers, and that is your GCF. So it's a pair of 2's and a pair of 3's. So I multiply 2 times 3. So your GCF is 6. So let's think about if that makes sense. Let's think about if you can still see it even with the line there. Let's see if that makes sense. Is 6 the biggest number that can go into 6 and 12? Think about that. 6 goes into 6, right? And 6 also goes into 12. So if you think of the factors of 6, 6 has a few factors, 6 times 1 and 2 times 3. And if you think of all of those, 6 is the biggest one. 2 can also go into 12, can't it? But 2 is not the biggest number that can go into 6 and 12. It is a common factor because it goes into both, but it's not the greatest common factor. And here we're looking for the greatest common factor. Luke and Travis, you can grab your stuff and go. It's 12:45. You don't want to be late. You were late this morning. You don't want to be late.
There wasn't a bunch of purpose you made it a flag.
Kind of does look like that. So I want you to put one more little thing into your notes. Looks like this. Yes, hold on. I want you to write, you can only match numbers that are in both. Meaning, you can't match numbers that are side by side. You can only match numbers that are 1 in each. Okay, go fast.
I don't know prime numbers. I don't.
So, prime numbers. I heard somebody asking about prime numbers. Prime numbers means numbers that only have a factor of 1 and itself. That's it. Prime numbers are numbers that only have a factor of 1 and itself. Okay? It's fine. They're on their way. Okay, so now I'm going to show you 2 different ways. Catherine, what's your question?
How do you know which numbers to multiply?
The numbers, she asked this question. How do you know what numbers you multiply together? You multiply the numbers that have a match. So we had a match, two 2's there that we matched, and then we had 2 3's. And that's how we multiplied 2 times 3. Because we had a match of 2 and a match of 3. Okay? All right. So we're going to do more examples so you'll be able to see it again. So here's another example. Way number 1. That's what that says. So we're going to try these 2 numbers, 12 and 30. Way number 1 was the way that we just did. The way that I showed you the first example. The reason why I started with, you can flip to the next page. The reason why I started with way number 1 was because way number 1 is the way that you have less chance of making an error and missing something. And you'll see what I mean once I show you what way number 2 is. So with way number 1, since you're finding prime factors, you don't accidentally miss a factor. And if you missed a factor and you missed the answer as your factor, then you'd get the question wrong. So way number 1 is a good way to make sure you don't miss anything. So remember, step number 1, you can look back in your notes, was to make 2 factor trees. So we're going to make a factor tree for both of those numbers. And so last time we used 6 times 2 for 12. This time we can use 3 times 4 just so you can see. 3 is a prime number. Now for those people who had questions about prime numbers, 3 is a prime number because the only numbers I can multiply together to get 3 are 3 times 1. Basically it means I can't break down the number 3 anymore. The only things I can multiply together to get 3 are 3 times 1. So anytime that the only thing you can multiply it by is 1 times itself, that's what makes it a prime number. 4 is not a prime number because I can also, besides multiplying by 4 times 1, I can multiply 2 times 2. 2's are prime numbers because the only thing I can multiply to get 2 is 2 times 1. So now I'm going to list my factors. Factors of 12 are 2 times 2 times 3. Take notes. Write down everything I'm writing. Okay. Now here's for 30. There's lots of factors of 30, but what's a pair that I could use for this? Hamza. 10 times 3. What else could you use?
6 times 5.
6 times 5. What else could you use? 15 times 2. Or 6. You could use 6 times 5 or 5 times 6. Right? Let's do
I don't think there's anything else to do.
5 times 6. 5. You could do 10 times 3. Just work through if you did 6 times 3, or sorry, 10 times 3, just go ahead and work through the rest of it, and you will see that you will get the same prime factors as I get on here. If you did 6 times 5 and you switch the numbers, same thing. Same thing if you did 15 times 2, you'll get the same answer. Then we break down the 6 into 2 times 3, and both of those numbers are prime. Yes?
I actually, for 12, I recommend 2 times 6 because it makes your job a little easier.
How so?
You'll see in the end. I don't want to give it away.
Because then
There's a 6 and then another 6.
6 times 2 would be... No.
it wouldn't make it.
Hold on. You always have to go all the way down to prime factors. So it doesn't actually make it any easier because I would still have 6 and 2. So the 6 I'd have to break down and the 2 would be prime. So it's, yeah. You always have to go down to the prime factors. Maybe you're thinking of way number 2, and I'll show you that in a minute. So for the number 30, now I'm going to list out my prime factors. Now here's one of the reasons why I told you to write the numbers from least to greatest. Because that way when you go to match up numbers, you don't have numbers all over the place. Like you don't have a 2 at the beginning and a 2 way over at the end and all that stuff. Sometimes what people have a question is, what if they're not right on top of each other? Can they still be pairs? Yes, they can still be pairs. So so I have this pair of 2's here. Now even though these 2 3's are not right next, like one on top of the other, you can still circle them. Your circle just looks a little weird like that. Now we don't have another 2 and we don't have another 5 to match. And so remember that was step number 2, was matching up my common factors. And then step number 3 is to multiply the 2 sets of numbers that I made. So I have a set of 2's and a set of 3's. So my set of 2's, I multiply 2 times 3, and it just so happens that my GCF is also 6 again. GCF is not always 6. That would just happen to in these 2 examples. So now I want you to think about it without making any noise. I want you to think about it. The greatest common factor of 12 and 30 is 6, right? 6 goes into 12 and 6 goes into 30, and there's not a number that's bigger that can go into both of those. Now 10 goes into 30, right? And it's bigger than 6, but can 10 go into 6?
You mean 12?
I mean 12.
No.
10 cannot go into 12, right? So it's a factor of 30, but it's not a factor of 12, so it's not going to be a greatest common factor.
And 12 cannot go into 30.
So way number 1 starts like this: making a factor tree, matching up the pairs, and then multiplying your pairs together. Ava, did you have a question? Okay. What if you had what? Just a pair of 3's? Okay, so here was Ava's question. I need everybody to be quiet and still. Make sure you're listening. Remember I told you you needed 100% focus on this one. Girls in the back, 100% focus. She asked, what if there's just one pair? That was a good question. So what if there's only a pair of 3s and that's all that matched? Then your answer would just be 3 because that's the only match. In this case, because I had 2 pairs, I have to multiply them together. Here's another question. What if there's no match? Sometimes there could be no match. So, because what if your number was like factors of, greatest common factor of 11 and 15? 11's a prime number, so the only numbers you can multiply to get 11 would be 11 and 1. And so, greatest common factor would be 1. If there's not a match, if there's nothing that will match up, then your greatest common factor is 1. Because 1 goes into every number, right?
Mm-hmm.
So, your greatest common factor would be 1 if nothing matches. And we'll put that into our notes. You're not going to get 0 as a number here. Okay, here's way number 2. I'm going to use the same numbers so that I can show you how you can get the same answer by using way number 2. Now, to use way number 2, you have to be really strong in your basic facts. If you're not really strong in your basic facts, way number 2 will not work for you. So you need to use way number 1 for every single problem. Also, way number 2 is not going to work if you have super big numbers, like if I give you 186. There's going to be a lot of numbers that can go into that. Because if you forget or you miss a factor, it's going to mess you up. Could possibly cause you to get the problem wrong. So way number 2 is just simply listing out the factors. So if I have 12, you want to find the GCF of 12 and 30. Remember I told you we're using the same numbers that we just used. So way number 2 is just listing out the factors. So factors of 12 are 12 times 1. What else? Nolan, what else?
6 and 2.
6 and 2. Angelina, what else?
4 times 3.
4 times 3. Anything else?
3 times 4. No, that's all.
But we listed all of the numbers. So 3 times 4 and 4 times 3 is the same thing. You don't have to list them in reverse. We know that. So factors of 12 are 12, 1, 6, 2, 4, 3. All numbers that can go into 12 evenly. Right?
Yes.
Karnpreet, can you move to this table right here? Now we're going to list out factors of 30. What are some factors of 30? I'll start you off. 30 times 1.
3 times 6.
What else, Malachias? 6 times 5.
15.
Hamza. 10 times 3. What else, Amy? 15 times 2. Did we miss anything? Did we get everything?
Yeah.
So now we look at the 2 lists and we just look for the biggest number that is in both lists. So do we have a 12 in this list? No. Do we have a 6 in both lists? Yes. Do we have, now that would be the next biggest, that's why I went from
The next biggest.
right. So that's why I went from the biggest number in the smallest list. The biggest number in the shortest list. So I took the shortest list, which was 12, and I found the factors of 12, and I just tried to see if 12 would go in here. If it doesn't, it's not going to be that answer. The next biggest number in this list is 6, because remember we're trying to find the greatest common factor. So the GCF is 6. You may use, now here's the part where you have to really pay attention and listen and think what's going to work best for you. Do you see why in way number 2, if you don't know your basic facts very well, how you might, like, what if I forgot about 15 and 2?
Then you get right.
And what if, let's just say, my second number was 45? So watch this. What if I have 30 and 45? And I go to list out my factors. That's a 5. It just didn't take all the way. So 10 times 3, 6 times 5, and let's say I forgot about 15 times 2. Let's just say I forgot. Then I try to find factors of 45, and I go, okay, 45 times 1, 9 times 5.
15, 3.
we could put 15 and 3. Maybe I remember about 15s on this one. And then I go, okay, and I start matching them up.
5 would be.
Then 5, is 5 really the greatest common factor of 30 and 40? Because I forgot about 15 times 2 up here. 15 is really the greatest. But do you see how if you're not really super strong in your basic facts, or you are trying to go too fast and you forget something, it could cause you the problem, could cost you the answer to the problem. So because I didn't have a 15 up here, I wasn't able to match up the two 15s because I forgot to put 15 in one of the lists. So my advice to you is, if the numbers are small, like 6 and 12, those ones were easy to just list out the factors because obviously smaller numbers usually don't have a whole lot of factors, right? And they're easier for you to work with because those are smaller numbers. When you get up to bigger numbers that are going to have more factors, that's when you run the risk of like forgetting one of the pairs. And if you forget one of the pairs, it could really mess you up. Now, sometimes you forget a pair that doesn't matter because it's not the greatest common factor, but the time that you might forget might be the time where you've actually missed the greatest common factor. So way number 1 is going to be for the people who aren't so good with their basic facts, that maybe need to make sure you get those prime numbers. Hold on. And also if the numbers are big, because we're going to see in here there's going to be some numbers that are big. Way number 2 would be to use if you have smaller numbers and if you're really strong in your facts. Okay, so 2 different tools, 2 different ways. On the assignment today, they actually ask you to use a certain way with a certain set. So they'll give you a set of numbers and ask you to solve using prime factorization. That would be way number 1. Then some of the questions they tell you in the directions to solve making a list of the factors, and that would be way number 2. But I'm going to change the directions and tell you that I want you to use whichever way works best for you on any of the problems. So don't worry about, I just wanted to expose you to both ways, because some people are going to choose to use way number 1 all the time no matter what, and some people are going to use way number 2 more often. Okay, so I want you to see both ways, but for the assignment today, you can choose which way works best for you, and it's probably going to depend on the question. So once you see the question, if you think you already know all the factors of that number, go ahead and list them out and do it that way. If you'd like to do factor trees, go ahead and do it that way, whichever way you think works best for you, and everybody's different. Yes?
What are we going to do for work tomorrow then?
We're just not gonna do all of the questions today.
Oh, so we're going to do it.
Right. So tomorrow we'll do our problem of the day tomorrow, and we'll do a couple more examples together, because this lesson, people tend to need a couple of days because the questions take sometimes a while to figure out if they're numbers that are bigger that you don't know. Like these ones I gave you examples of were easier, but once you get into some bigger numbers, it makes it a little harder. All right, let's look at, yes, they can. I wanted to also show you some things about divisibility rules. So before we do this example, I'm going to hang up a poster in the back, and I'm going to show you a little bit about divisibility. Okay, so the divisibility chart, listen, the divisibility chart is going to hang on the board for today and tomorrow especially, so that you can use that chart to help you with all those tricks. So if you have some spare time later and you'd like to copy some of those rules into your own notebook, so that after the poster comes down, you'll still have access to it, and while you're at home, you'll be able to help with those rules too. Okay, so those are just kind of tricks to help you. All right, so example number 1 says that Seversville Middle School arranges their sports trophies in rows in a display case. There is an equal number of trophies in each row. Each row only has one kind of trophy. So what is the greatest possible number of trophies in each row? And in this example, there are 3 numbers. So whatever we are pairing up, we're going to find the prime factorization of each number, and then we're going to find the number that they have in common, just like we had done before. So because this one is our example, they gave us some boxes, so they gave us places to start. So for 40, we'd have 4 times 10, and they've already broken down the 4 for us into 2 times 2, so I'm going to go ahead and circle it. And then 10 would be 2 and 5, which I'll circle. Then we're going to find the prime factorization of 24. So they've done 4 times blank, which would be 6. And they've found the prime factors of 6 for us. And then the prime factors of 4 are just 2 and 2. Oh, you have bloody nose? Yeah, just go to the office. Take the pass. Here, let me open the door for you. And then hold this in your hand so that you can open up the door to the office, okay? So you don't touch it. Okay, now numbers, factors of 32. 4 times blank. So what's going to go in the blank? What's going to go in the blank? 8, because 8 times 4 is 32. So 4 is broken down into 2 times 2. 8 into 2 times 4. So now we have, man, 32's got a lot of 2's, right, as their prime factors. So now let's go to the next. Go to the next slide. You're going to look just down on your paper. So when you went to match up all of those factors, I want you to circle all the pairs that you see. How many pairs of 2's did you have there?
7.
How many pairs of, not how many 2's, how many pairs of 2? That means 1, 2 in each list.
6.
I see some 4's. I see some. It's not how many 2's you see, it's how many 2's that match up. The way that it's written is kind of confusing, and since I don't have that slide, I'm going to rewrite what all the factors are. 40 would be 2 times 2 times 5. Wait, 2 times 2 times 2 times 5. I missed one. The factors of 24 would be 2 times 2 times 2 times 3. And the factors of 32 are 5 2's. So now I have to, okay, so these people are saying 4, but these only have 3. How can my answer be 4? Look, I've got 3 2's here. So I got a 2 in every one. I've got some here, and I've got some right here. These do not count. These are probably the ones you guys are counting. Why don't they count? Someone tell me why they don't count. That's like a number 1 mistake. Ava, why don't they count? They are in the same row. They're in the same number. So those 2's both came from 32. In order for you to count them as pairs, or in this case as triples, they have to be in every number, not in the same row. So these ones do not count because they are not in the same, they are in the same row. And this doesn't count and this doesn't count because they don't have matches. So 2 times 2 times 2, and I heard somebody say 6. Uh-oh. What is the answer here?
Wait,
Seema, what do you think? 8. Seema says 8. 2 times 2 is 4, and 4 times 2 is 8. So your greatest common factor is 8. It's not 6. It would be a 6 if these were addition signs. Those are multiply there. It's kind of like when we do exponents. It would be like 2 to the 3rd power. 2 to the 3rd power means 2 times 2 times 2, which means 8. Bryson.
Can you find the greatest common factor of a prime number?
The greatest common factor, okay, so if you're looking up factors of a prime number, it would just be 1 and itself. So it's pretty likely if you have 2 prime numbers, or if you have 2 numbers that don't have anything in common, then you would just say the greatest common factor was 1. Because 1 can go into every number. All right, let's look at the second example, then I'm going to let you get started. Example number 2. This shows using way number 2, listing out the factors. So they made an organized list of the factors for each number, and then they want you to circle the common factors. So I have, oops, sorry about that. I have 2's here. I have 3's here. I have a 6 in both lists. Now they said an organized list. An organized list means in order from least to greatest, makes it organized. So what's the greatest, the common factors are, oops, I forgot the ones. 1, 2, 3, and 6. So what would be the greatest common factor? 6. It's the biggest number that fits into both, right? So on this case, now, way number 2 seemed easy on this one because they did all the factors for us. That's the hard part. So on this one, they did the factors for us with way number 2, which made it look real easy. But if we have to make the factors ourselves, this is where you may accidentally forget something. Okay, so remember to keep in mind to try to use the list only if the numbers are smaller. I want to show you one example of something that Bryson mentioned. So I'm going to forward to your assignment here and find one that fits what fits his question. Unless there isn't one like that, and that would be nice.
There isn't one like that for movie? Well, that's homework, so we can't do that.
I don't even see any like that. So here was my here was what I was going to show you. I'll just do it on the bottom of this paper here. So if you have two numbers like 11 and 20, 11's prime. So guess what I could do? I could just circle it.
And say 1.
Or I can go like this and put 11 and 1 because that's all I have. And then 20 we could 5 and 4, 2 and 2. So my greatest common factor would be 1. The mistake that some people make is they put 0. Like greatest common factor, none. And that's what they write. You can't write none or 0. You would put 1 if there's nothing that's in common. I said that earlier, but I wanted to make sure it's clear in case you see one like that. Okay? That's just in case. He asked that question, so I wanted to make sure I went over what would you do if that happened. Okay, so for today's assignment, I would like you to just do the even numbered problems. So, I'm going to circle some numbers here for you. If you want to follow along with me, feel free. That way you don't do too much work.